Section 8.2, get ready to write, loosen it up. We got a lot to write down about our properties of parallelograms. You have this on your handout, and you have room to write properties underneath as long as you don't write way too big. If you write way too big, you're not going to fit all these. If a quadrilateral is a parallelogram, then, and as you can see, that is going to be a conditional statement like we worked in the first semester, chapter 2. If a quadrilateral is a parallelogram, then what's true about it? So first it has to be identified as parallelogram. Then you would know that both pair of opposite sides are parallel. Both pair of opposite sides are parallel. Pretty much that is the definition of a parallelogram. But because it's the definition of it, it still becomes one of its properties. Pause the video if you have to, so you can write fast. If a quadrilateral is a parallelogram, then opposite sides are congruent. Both pair of opposite sides, this way and this way, are congruent. Opposite angles are congruent. Consecutive angles are supplementary. Remind yourself 2 vocabulary words right within this own property. Consecutive angles, they're next to each other. They're not across the parallelogram from each other. If they're not opposite angles, they're consecutive on a 4-sided figure. Supplementary, they're going to add up to 180 degrees. Throw that on there if you are afraid you're going to forget and think that it's complementary or a 90. And their diagonals also bisect each other. Write down those 5 properties. We're going to take a look at the first diagram. That's being identified as a parallelogram. If it has this property or definition, both pair of opposite sides are parallel, then we know it's a parallelogram. This pair is parallel, that pair is parallel, you know it by the markings. You can put a symbol, if we know that quadrilateral FGHQ is a parallelogram, you can actually draw a parallelogram in front of it. We don't do that for all the other quadrilaterals, but for a parallelogram we will. So that you are told that parallelogram FGHQ is a parallelogram. Okay, first property, both sides are parallel. Next property, opposite sides are congruent. So we can mark these sides opposite, and in the book it'll be with a red tick mark. And we can mark these sides opposite. Just because they're parallel does not automatically mean that they're congruent. So we have to add the tick marks to it to show opposite sides are congruent. Next, opposite angles are congruent. If we measured angle Q right here, we would find out that it's the same degrees as angle G over here. Single arc marks that way. But then we would need double arc marks going the other way to make sure all 4 of them are congruent. Angle H is congruent to angle F. That's 3. Fourth one. Consecutive angles are supplementary. So the measure of angle Q plus the measure of angle F is 180 degrees. They are supplementary. The measure of angle Q and the measure of angle H is 180 degrees. And we could list all of them. The measure of angle H and the measure of angle G are 180 degrees. The measure of angle G and the measure of angle F are 180 degrees. The only ones that aren't 180 degrees are the ones that are opposite of each other. That's 4. The 5th one, diagonals bisect each other. If diagonals bisect each other, it's basically telling you that a diagonal from Q to G, if you draw one diagonal, that doesn't do anything. But if you draw the other diagonal, even though these diagonals are not the same size, that's really not a very straight line, segment. Even though they're not the same size, you can be told that they bisect each other. So that this diagonal right here is cut in half. This diagonal going this way is cut in half. This is technically a midpoint. M is the midpoint between QG and between HF because it cuts each one of those in half. And there are your 5 properties. Next up, you're told up there in the corner that parallelogram FGHQ, it's a parallelogram, using the properties. So basically these are telling you, here's how you set up the problem. You have to go back to the properties and look. If I'm looking for x, what do I know about x plus 4? Go find the property that says opposite sides are congruent. Congruent means equal. X equals 8. Notice I'm not going to give you very difficult math. It's just the idea of setting it up to match the properties. I want to find angle H. I can't compare it to angle G because I don't know. I can't compare it to angle Q. I don't know. But I do know that opposite angles are congruent. If opposite angles are congruent, then Y has to be the same size as angle H. You're just picking out the properties and using them mathematically. Here's another way of drawing a parallelogram. Instead of the big filled-in triangles, you could just use those kind of like little arrows, but it still means parallel. The only thing they told you was that this little piece was 5 and that little piece was 3. All right, how long is YT? How long is AT? Go ahead, you write those down yourself first. Pause it and come back. All right, you're back. Did you decide that YT is also 5? Because opposite sides are congruent. Did you decide that AT, oh careful, A to here is 3, which means here to here is also 3, which means all the way from A to T is 6. If the measure of angle AYT is 70 degrees, AYT is 70 degrees, so we're going to make this mark, which means all the way across, all of there, is 70 degrees. Find the other 3 angles of the parallelogram. The other 3 angles of the parallelogram, which means we have to name them separate from this. This is a different problem. I just left room over here. Measure of angle AYT. We can't call that angle Y because there's too many angles at vertex Y. We can't call this angle A. We can call it angle YAX. So we're going to say the measure of angle AYX. Then we need the next one. We can't call this angle X. It's going to be measure of angle AXT. And down in the corner, we can't call that angle T. We can call it angle, we can't call it angle T. We can call it angle XTY. XTY. Go from there. How big is each angle? Maybe it's easy to find the one opposite first. Opposite angles are congruent. So if angle Y, AYT down there is 70 degrees, so is measure of angle AXT. How do we find the other 2 angles knowing that they're not congruent? We go back up to our list. What else helps us? Consecutive angles are supplementary. Oh, well, that's good to know. Supplementary adds up to 180. If this is 70, this has to be 110. If that's 110, that's 110. Degrees, make sure you throw your degrees in there. So not only do you have to come up with how big the other 3 angles are, you also have to name them properly. If you called it XYA, you're okay. AYX, you're okay. Angle Y, not okay. Over here, separate problem. The measure of angle AXT is 3x. So that's up here in this corner. I'm going to get rid of this. Measure of angle AXT, so all of this is 3x. The measure of angle XTY is 120. This again goes back to chapter 1. Can you name your angles properly? XTY is 120. So I'm going to get rid of this. I'm going to go XTY. This whole corner is 120 degrees. You have to ask yourself, are those opposite angles that are congruent? Or are they consecutive angles that are supplementary? Hopefully you answer yourself as consecutive angles that are supplementary, which means you'll take 3x plus 120 and set it equal to 180. 3x then must equal 60, and when you divide, x equals 20. And that's all they wanted, just said find x, so you're good. Last 2, find the variables of each of the following parallelograms. Go ahead and solve that yourself. Pause the video and come back and see if you got it right. Okay, there's your results. If you got x equals 1 and y equals 3 on your own, then just keep going. If you didn't, pause it and take a look at all the work up there and see what you possibly did wrong in the setup or in the solving. All right, next problem. This time it looks like we're working with the diagonals. The only thing that you know about diagonals is that the diagonals are congruent. Nope, they are not congruent. I'm thinking of a different quadrilateral. They bisect each other. They definitely are not the same size. If you look at these two diagonals, this one is way longer than that one is. If they bisect each other, that means each half is congruent. But I can't set 3f minus 1 equal to 2g plus 4 because that's two different variables. But I can work with these diagonals. So how about if I do 4f minus 8 equals f plus 1? We'll solve that by minusing f from both sides. We can also add 8 the other direction to both sides, which gives us 4f equals, nope, how about 3f? Gotta be able to subtract. 3f equals 9, and if you divide 9 by 3, you end up with f equals 3. Use your answer, which I always tell you not to do because it could be wrong, but in this case you have to. If you know that f is 3, then we have to go 3 times 3 minus 1 is 8. Once you know that that's 8, you'll take 2g plus 4 and set it equal to 8 because diagonals bisect each other. 2g equals 4, and when you divide by 2, g equals 2. So, do you have to memorize these properties? Absolutely. All 5 of them, memorize them, because when you're given a test and say, hey, find this. Yes, the math of this is super easy, and I didn't give you any difficult equations, but if you can't set it up, then you can't solve it. And if you can't set it up, it means you don't know the properties. Do you know that opposite sides of parallel opposite sides are congruent? Consecutive angles are supplementary, but opposite angles are congruent, and that diagonals bisect each other. It's not that hard. Figure it out, or at least be able to figure it out by looking at a diagram. Once you see a diagram, can you come up with all 5 properties? But that's what you're working on this section. Good luck.